Dear friends, Maths Aspirants is a community of math students, research scholars, and teachers initiated by myself in the year 2017. And we used to arrange online problem solving sessions to help the students who prepare for different national level competitive examinations like CSIR NET, GATE, JAM, etc. Today, we are having a session on complex analysis, which will be very useful for CSIR NET aspirants, as well as for those who prepare for NBHM GATE exams, etc. So today we have Miss Sneha B, a research scholar from Indian Statistical Institute, Bangalore, is with us to discuss some topics of complex analysis with us. Ms. Sneha done her B.Sc and M.Sc from Dean College, Chittoor, Palakkad, Kerala, and she cleared both the exams, B.Sc, both the degree and PG with first rank in University of Calicut. Also, during her MSc, she qualified CSIR NET with all India rank 70, as well as GATE examination. And also, he is one of the recipient of NBHM PhD Fellowship 2021. So I am very happy to introduce Ms. Sneha in this platform. She's a participant of our Math Aspirants groups since her college days, and I would like to welcome Sneha, and I express my deep gratitude to Sneha for being with us for such a session on complex analysis. I hope that today's session will be really very useful for those who are planning to write this CSIR NET examination, and Sneha will discuss some questions from the previous years of CSIR exams from the area of complex analytic functions. Okay, welcome everyone. Welcome Sneha.
First of all, I express my sincere thanks to Dr. Vinod Kumar sir for giving me such an opportunity to present complex analysis of CSIR NET, which is my favorite subject, in front of you. Okay, today we will be doing some problems in complex analysis. But just dealing with some problems in complex analysis will teach you only those problems further. And if you are not able to make a meaning out of these problems, then it will be of no help for you. So I thought of giving some introductions in complex analysis, basically with the theorems that we use repeatedly for NET exams. So I'm not completely explaining complex analysis basics, but I am just giving some results in complex analysis that will help you in your NET exams. Basic definitions everyone will be knowing. What is a function, and what is a complex valued function, and what is meant by differentiability at a point of a function, so on. Even you have been studying these things right from your B.Sc classes. So I hope everyone will be knowing that. And in complex analysis, there is some more general term than differentiability. It is analyticity. This analyticity is making lots and lots of theorems for us in complex analysis. So let us begin with differentiability and analyticity. Okay, if we are given a function f, like this, f, and f is of the form u plus iv. What is meant by u plus iv? The real part of the function, and v is the imaginary part of the function. And I am here claiming that f dash exists at a point z. Then we have ux, uy, vx, vy means the first order partial derivatives of u and x. U and v exist and they satisfy Cauchy-Riemann equations. What is Cauchy-Riemann equations? It is ux equal to vy and uy equal to minus vx. So what we have said is that if a function is differentiable at a point, then at that point, its first partial derivatives of u and v exist and the CR is satisfied at that point. But we need the converse part. Always the problem is that given a function, is it differentiable or is it analytic? That is the problem that we always face. So there is a necessary and sufficient condition. The sufficient condition we have discussed it. Now comes the necessary condition. Instead of having differentiability at a point, if f is defined on a neighborhood of z, and if at z, ux, uy, vx, vy all exist and the CR is satisfied, then f dash exists and it is equal to. So we know that f dash z exists and we have a specific form for the derivative of f. What is it? It is the first partial derivative of ux plus I times first partial derivative of v with x. Okay, clear?
Yes, ma'am.
Yes, ma'am.
Okay. And now comes the CRE in polar form. In some problems we will deal with CRE in CRE in polar forms. Most oftenly it will be in the coordinate forms, but in some cases we need a polar form. So it is better to understand what is the polar form also. So the CRE of the function f equal to u plus iv in polar form is r ur equal to v theta and v theta equal to minus r vr. Okay. Now comes what is analyticity. We know that differentiability is spoken about a point, say set naught. So analyticity is again spoken in terms of a point, but it is little more type of neighborhood kind of thing, because we are saying that analytic at a point, f is analytic at a point if it is differentiable at a point and if we can find a neighborhood u of z naught at which f is differentiable on each of the points of u. Hope the definitions are known and clear. Now comes the main results that we are going to use while doing problems, and there are some other results beyond these given results which will be effective. You can get it from any of the complex analysis books, and basically I suggest Brown and Churchill book in complex analysis for problem solving, not the exercise parts, but the theorems can be easily applied to the problems of CSIR NET exam. And some of the theorems are given here. We will be looking into it one by one. So if you are given a domain D, what is a domain? It is an open and connected set in complex plane. So if you are given a domain D on which the derivative of a function is vanishing, means it is identically equal to 0, then we can conclude that f is a constant in D. Note that it is the property of analyticity or differentiability. But this cannot happen when we are losing some point of differentiability. Okay, so in complex analysis, this is an important result. F dash is 0 identically on D implies F is constant on D. Now comes the theorem which gives really many applications to CSIR NET exams question, because they used to ask frequently about constant entire bounded, then poles, residues, and so on. So most often we can use this theorem, and either we can select an answer from the options or we can neglect an option. So we will look into it. Let f be an analytic function, then f is constant if one of the following holds. What is it saying? If real part of f is constant, then f again is constant. If imaginary part of f is constant, then f is constant. If modulus of f is constant, then again f is constant. if argument of f is constant, then also f is constant. And if f conjugate is also analytic, then f is constant. These points you have to remember. These are all small proofs which you can do in 1 or 2 minutes. So I am not getting into the proofs of any theorems, but you have to know all these theorems. And next is Cauchy's theorem, which almost all will be familiar. What is Cauchy's theorem telling you? If f is an analytic function at all points interior and on a simple closed contour C, then integral over C f is at dz is 0. So a simple closed contour is something like that. There must not be any crosses like this. This is not a symbol. This is not a simple contour. This is a simple contour and it is closed also. So if you are given a closed contour which is simple, and if you are given a function f which is analytic on and inside C, then we can say that integral of C f is at dz is 0. Okay. Now, let f be an analytic function inside and on a simple closed contour C. And if Z is in interior of C, then integral over C f is at z minus z naught dz is 2 pi I f of z naught. This is Cauchy's integral formula. Okay. So what is Cauchy's integral formula telling you? Every theorem aims to integrate a function on a closed contour C. Simple closed contour C. So this theorem tells you that if we have a simple closed contour, say C, and f is analytic inside and on the complex, on the closed contour C. So this is the closed contour and f is analytic inside and on the contour C. Now there is some issue with the Cauchy's theorems and integral formula. What is this telling? This is the entire integrand. But you must note that f is not the entire integrand. There is a z minus z naught part in the integral. And we are assuming that at z naught, there is a singularity for the entire integrand function. Okay. Then it is saying that it is just 2 pi I f of z naught. So these are the formulas which we have to remember, because I have seen many times in CSIR NET question papers that they directly ask questions so as to integrate a function on a simple closed contour. And we will look into it in the problem section also. So now we have the consequences of Cauchy's integral formula. Mainly 3 consequences or maybe 2 consequences I have written, because these are useful for neglecting an option in CSIR NET. So what is this? If f is analytic at a point Z, then its derivatives, higher order derivatives, are also analytic at that point Z. What is this? It is the nth derivative of f. So remember, if f is an analytic function at Z, then every derivative of f is also analytic at Z. Now, the next consequence is that if f is analytic at Z, then u and v, where f equal to u plus iv, have continuous partial derivatives of all orders at Z. Means ux is continuous, uy is continuous, uxx is continuous, uxy is continuous. Similarly for v, everything exists and it is continuous. Okay. The next result is that Cauchy's integral formula for higher derivatives. Later we were discussing the Cauchy's integral formula for n equal to 1 here. Now we are discussing for any n in n. So the assumptions are same. F is analytic inside and on a closed contour C. F is analytic inside and on a closed contour C. Then Z is, if Z naught is in the interior of C, then what we are telling is that instead of z minus z naught, if we have a function like this, f is set by z minus z naught power n plus 1, then it is 2 pi I by n factorial nth derivative of f at z naught. So this is also important because as similar to the Cauchy's integral formula in CSIR net exams, we also do get some questions in this area directly, because they will be just giving some closed contour and they will be asking to find some, say, e power z by z minus 1 square dz. So these type of questions occur in CSIR net exam, so we should not skip the formulas. Now, next is a very important theorem which we use frequently in almost all problems in complex analysis. It's Liabilities theorem, and it has got some modified version also. This is also very important. So, Liabilities theorem is saying that if f is an entire and bounded function, then f is constant. What is an entire function? It is analytic on the entire complex number C. So, if f is entire and bounded, then f is a constant. So suppose you are given an entire function which is not a constant, then what is the conclusion that you can obtain from that? Someone please tell. If f is given to be entire, but f is the non-constant function, say f is given to be z. So this is an entire function and it is a non-constant function. Or even if I am giving z sine z, this again is an entire function and if it is a non-constant function. So what can you tell about f in case of boundedness or unboundedness?
Ma'am, oscillatory. Oscillatory.
Oscillatory. No, I'm just asking whether f is bounded or not. Or
Ma'am, it's
is
unbounded.
it that we can't predict it or something like that?
It will be unbounded.
Yeah, it is unbounded, because if it was bounded, then Liabilities theorem says that entire plus bounded is a constant. So it is just a contrapositive of this statement. So we used to use Liabilities theorem in this manner rather than its direct consequence. And there is another version of Liabilities theorem. It says that if f is entire and instead of boundedness, it says that it is bounded by some constant multiple of the polynomial z power n. Then we say that f is a polynomial of degree at most n. Okay, this is again an important fact which we use in neglecting the answers. So the next is that consider power series, this thing. Then we all know that the radius of convergence is given by this thing. Here we have to be careful that we will always be doing mistakes in R and 1 by R. So it is better to learn the radius of convergence formula instead of learning 1 by R. So it is R equal to 1 by limit supremum of mod a n power 1 by n or limit supremum of mod a n by mod a n plus 1. And then comes the most important theorem, Little Pickard's theorem. Little Pickard's theorem says about a non-constant entire function. Slightly different from Liabilities theorem. We all know that if f is non-constant and entire, then from Liabilities theorem, f is unbounded, right? But Little Pickard's theorem says more about f. What it says is that the image set of f or the range of f is precisely C or C minus a single point in C. It cannot be of the form like this, or it cannot delete more than one point. The range will be precisely C or C minus a single point. Now comes the next theorem, which we frequently use, but most often we cannot understand, okay, the identity theorem is to be used. So we have to be careful while using identity theorem. So identity theorem says that if I have F and G analytic on a domain D, okay, so some domain I have, this is D, and if I have F and G, which is analytic here, and if I have some set, say E, where F equals G, on E subset of D, I have F equals G, and if I have a limit point, and if there is a limit point for E, say set not or something, in D, then we say that F is identically equal on D. Is there any chat box comment?
No, Sneha, they are simply typing their names.
Okay. Okay, sir. Thank you. Okay. So identity theorem is useful. You have to understand it carefully. If we are given a domain D on which two analytic functions are given, say F and G, and if there is a subset E of D for which F is identically equal to G on E, and if E has a limit point in D, then we say that F is identically equal to G on the entire space D. Okay, then comes maximum modulus principle. This is also really useful. Okay, what is maximum modulus principle saying? If you have a domain, say U, whatever notation I take it for domain, no matter, U is a domain, and if F is analytic function on U, and if I am claiming that there is an element, U means it's open, don't think that if this is a closed set, it's open set, and if there is an element set not inside U, having the property that the maximum value of the function F is attained at set naught. What does this mean? The maximum value of F in U is attained inside U itself. Then F must be a constant. This is the result. So it means that for a non-constant analytic function, F cannot attain its maximum value inside U. And in fact, it is attained in the boundary of U if F is a bounded function and U is a bounded domain. So maximum modulus principle is used often. Now, next is an open mapping theorem, which again is used for negating or neglecting an option in the questions. So what does open mapping theorem tells us? If U is a domain in C and F from U to C is non-constant holomorphic function, means same as analytic function, don't worry, then F is an open map. What does it say? If we have a domain U and here we have a analytic non-constant function. Analytic non-constant function. Then what we have is F is an open map. What is the definition of an open map? F maps open sets of X to open sets of Y. If F from X to Y is a map, we say that F is an open map if F maps open sets of X, open sets of Y. Okay. So what is peculiar about this and Liabilities theorem? There is a difference. You see, in Liabilities theorem, we cannot take a domain as we wish and say that if F is analytic and non-constant there, then it is unbounded. No, that is not true. Liabilities theorem holds only for C, the entire functions only, not an analytic function on a domain. But this speaks about an analytic function on a domain. So if you have a domain U, and if you have an analytic and non-constant function on U, then we say that F is an open map. Okay. Now the next is Swas Lemma, which is the most important result. So it says that if F is again a holomorphic map from unit disk to itself. What is a unit disk? This is a unit disk of radius 1 and centered at 0. Okay. If f is a holomorphic function that maps unit disk to unit disk, such a fashion that 0 is always mapped to 0. Then I have mod f is always less than or equal to mod z, and mod f dash at 0 is less than or equal to 1. Okay. Now comes the Cauchy residue theorem. Instead of using Cauchy's residue theorem, we can apply Cauchy's integral formula also in most of the problems, but it is good to know about Cauchy's residue theorem. So if C is a simple closed contour, which is in positive sense, means anti-clockwise direction, that's all. Positive sense, and if F is analytic inside and on C, except for a finite number of singularities. That is, if we are given some C, which is closed, simple, and given anti-clockwise direction. And if we are given an F, which is analytic inside C, except for some points inside C, in the interior of C, then what is integral over C? F is a dz. It is 2 pi I sigma k equal to 1 to n residue of z k f is it. And you all know the formula to calculate residue I2. If it is a pole, it is different. If it is a isolated singularity, we have 3 cases, and you all know the formula. But calculating residue from the Lorentz series will be most easy. Okay. Now, last theorem. If f is analytic and limit z tends to infinity, mod f is equal to infinity, then f is necessarily a polynomial. This is what we used to have exactly in one of the options. Most often when questions are asked from the liability part or the maximum modulus principle part, they're used to have such a option which we can neglect or accept accordingly easily with this result. So what does it tell? If it is unbounded near infinity, that is the meaning of this thing. If set tends to infinity, mod if a set is tending to infinity, then f is a polynomial. So are you clear with the theorems that we discussed? Do you need to look into it once again?
Ma'am, can you say about entire function and analytic? What is the difference?
Okay, analyticity, we are talking about a point. F is said to be analytic at z0. Okay. Means we can find a neighborhood, say U, of z0. On this neighborhood, f dash exists. Clear?
Yes.
But entire means this happens for each z0 in C. That is, f is analytic at each point z0 in C, the entire complex plane. Understood? So you are thinking that.
Okay, ma'am. Analytic means z0 at z0. It is in neighborhood derivative exists. Then every neighborhood point also derivative exists. Mean near they have some neighborhood. Like this way, we can see that analytic function is.
The point is that the derivative exists means this point may be some set. At this point, f is differentiable. Okay, f may be analytic because you may be getting such a small neighborhood around Z. So each and every neighborhood may sit inside U itself. It may not extend to C. Understood?
Okay, okay.
But for entire set not means, entire C means whenever you take a set not in C, there is some neighborhood. So you are going to take a set not outside this point. Again, there is a neighborhood. That is the difference.
Ma'am,
Yes.
polynomial function is unbounded
Which function?
in last 17 theorem.
17th theorem.
No, it's 18th, ma'am.
Okay, 18th. Polynomial function. What do you want to know about polynomial function?
Here the limit is unbounded.
No, I'm saying that if this limit is unbounded, then it is a polynomial. I'm not claiming that if it is a polynomial, then limit is unbounded. No. Because we can take the constant polynomials. Then its limit is not unbounded.
Okay, ma'am.
Okay. Any more questions?
Ma'am,
Yes.
ma'am, analytic and holomorphic are same.
Yeah, in fact, if we are defining it on some particular neighborhood or some small space, it is slightly different, but as a whole, analytic and holomorphic are exactly the same. And we can prove that analytic and holomorphic are same in some methods.
And ma'am, this polynomial function is analytic in everywhere.
Yes, yes. Polynomials are entire functions.
Okay.
Any other questions?
Ma'am, can you give some relation with precisely analytic and holomorphic and entire? Then which one is contained?
What? I
like
couldn't
this?
understand.
If you give some relation with analytic, entire, and holomorphic, then it will be better to understand.
Analytic and holomorphics are precisely the same. There is a difference between entire and analytic function. That's all. Entire and analytic function, I already gave the difference. Analyticity is mainly discussed at a point, but holomorphism is discussed on a neighborhood. But if we have holomorphism on a neighborhood, then we have analyticity on each of that points on the neighborhood. So precisely, analyticity and holomorphism are the same. Holomorphic.
Okay, thank you.
Okay. Any more questions? Feel free to ask questions. Okay. So then we can move on to the problems. So while doing problems, I will be giving an idea of the question. You have to work on your own. And once you are finished, you can unmute and tell, I am finished. But don't tell the answer. Say it's B or C. Don't do that because everyone needs their own time to do. After 2-3 minutes, I will be explaining the answer of each and every problem. So we shall start with the first problem. We are given a function f z equal to z cube plus 1 into z square of z. And this is my short name for which of the following are true. If I write f here, then it is which of the following are false. So the question is, given a function, we need to identify which of the options are true. So the first option is saying that if f is, say, u plus iv, u from R2 to R is infinitely differentiable. The second is saying that u is continuous, but it need not be differentiable. C is saying that u is always bounded. And D says that f can be represented by absolutely convergent power series. It is just an application of the results we have discussed purely based on CRE, then consequences of Cauchy's integral formula, then Liabilities Theorem, and Taylor series expansion. So think a while. This is very simple. So I will answer just after 1 minute. If you get an answer before that, please let me know. You can put in chat box or you can unmute and type. No matter if you are not getting an answer, but at least you have to think how to approach an option of this question. At least one option you must be able to do. And you must not lead to factorizing f into u plus iv form. That will take a lot of time from us, and we are not going to qualify CSIR net if we are doing in a straight manner that we do in our regular classes. So we have to negate or choose the options from the known theorems or results. Looking to the function, think what type of function is this, and then remember the properties of those functions. If you are done, you can tell me now. Anyone can tell. Let it be wrong, no matter. But you must be able to answer something about this thing. Okay, you understood this is some kind of function. If that is fine. Is there anyone who got at least one of the options? Open up.
Ma'am,
Yes, tell.
ma'am, if is not bounded because z cube is if is entire and it is by Liabilities theorem we can tell that C is not true.
Okay, very good. So at least from the theorems that we discussed, she was able to discover something out of this. So what she said, clearly f is not a constant function that we can see, right? And it is a polynomial times a trigonometric function. So this is analytic also. So now we have entire plus non-constant function. So I told you in the beginning that we will be using Liabilities theorem in this direction. So what does that means? It is unbounded by Liabilities theorem. So this option is false. Okay, some other options?
Ma'am, f is analytic at z, so the real part u is infinitely differentiable.
Yes. We also discussed it as a consequence of Cauchy's integral formula, right?
Yes, ma'am.
Yes. Now, since A is true, B is automatically false because it says that it need not be differentiable, but it is infinitely differentiable. So B is always false. Now, what can be told about the D part?
Ma'am, by Taylor series it is
Yeah,
infinite.
Yes. For an entire function, we will be having a Taylor series expansion converging to that f in absolute sense. So this is true. So look how easy you could be able to do a problem from C part complex analysis. So you are going to get how many marks out of this? It is 4.75 marks, which makes lot of differences in rank. Okay.
Ma'am,
Yes.
given function at z equal to -1 is not differentiable at this point.
What?
Function at z equal to -1, it is not differentiable.
Give a function at z equal to -1, which is not differentiable. That's what you are asking? Can you make the question more clear?
In option infinitely many differentiable, so I have doubt.
Oh, you are saying that it is infinitely differentiable is wrong. Why?
Function is not differentiable at this point, z equal to -1.
Oh, function is not differentiable. Why?
We take at this point -1.
Okay, if you took -1, what happens?
Function is 0.
But if function is 0, does that mean it is not differentiable?
Yes, ma'am.
No, because you can take the constant function 0. It is differentiable, right?
Yes, yes.
Yeah, it does not mean that if we substitute a value and get 0, then it is not differentiable. Maybe you are thinking about this 1 by z cube plus 1. That I agree, it is not, because it is not analytic. It has a singularity at -1. This comes in the numerator here. So it's an analytic function. Understood?
Yes, okay, ma'am.
Okay. So we are moving on to the second question. All these questions are taken purely from the previous year question papers of CSIR NET exam. None of them is made by me. So you can see that they are asked a direct problem. If C is a closed contour, which is given counterclockwise direction, and C is given as the circle with a radius 1/2, center at I. Then they are directly asking you to compute integral over C dz by z power 4 minus 1. So we shall look into the problem. What are they giving? They have given a closed contour. So what is given? It's of radius 1/2 and center I. Sorry. So this may not happen. Its center is I and its radius is 1/2. Okay. So the origin is somewhere here. And it is given that it is in the counterclockwise direction. So now just you are asked to find the value of this integral. How will you proceed? Just tell me the theorem that supports us to do this.
Cauchy's integral.
Yes, clear. Cauchy's integral formula. But can we apply Cauchy's integral formula directly here?
No, ma'am. We have,
Residue theorem.
Okay, residue theorem is also fine. Yeah, no, why? Because
Directly cannot apply, ma'am.
ma'am, we have to take center at I.
even if we take center at I, is it possible? In fact, it is center at I.
We have to add and subtract which is required.
Okay, but that may not work because -1 is there in the denominator, so you can't do anything with that.
Can we split, ma'am?
Yeah, we can split it, right?
Z square -1 and square plus 1.
Okay, so when we are given such a problem, first we will be looking into its singularities. Singularities of what? The denominator. Because the f set here is always the constant function 1 in the Cauchy's integral formula. So what is z power 4 minus 1? It is z square plus 1 into z square minus 1. Again, what is this thing? It is z plus I into z minus I into z plus 1 into z minus 1. Right. Is that true? Are you with me?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay. So what are the possible singularities of this function? They are I minus I, 1 minus 1. But we have to bother only the functions with only the singularities which are inside C. Right. So which singularities are inside C? It is a circle with the center I and radius 1 by 2. What are the points inside C? Is I inside C?
Yes, ma'am.
Okay, so I is one singularity. Is minus I inside C?
No, ma'am.
No,
No,
ma'am.
minus I is somewhere here. So it is okay. So it is okay to have minus I. So is 1 inside C?
No, ma'am.
No, ma'am.
No, ma'am.
So is minus 1 inside C?
None other
No,
than
ma'am.
I.
No, ma'am.
No, none other than I is inside C. So in fact, we can modify this problem as like this. F is at D is at by the only singularity is I. So we are going to write it as Z minus I. Understood? Where what is F is Z? It is 1 by Z plus I into Z plus 1 into Z minus 1. Okay. So when you put F is Z by this thing, what are you getting? The original question. So now we know that F, this function is analytic inside and on C. Right. Then what can we use? Either residue theorem or Cauchy's integral formula. But here Cauchy's integral formula is straight to use, right? What is the Cauchy's integral formula telling us? Then the integral will be 2 pi I into f of this singular value I. Okay. What is f of I? It's 2 pi I into 1 by substituting I here, we will be getting 2i. Yes.
Minus
What is I plus 1 into I minus 1?
minus 2 total.
Yeah. It is I
Minus 2,
square
ma'am.
minus 1, so it is minus 2. So what will happen here? It is minus pi by 2. Simple, right? We are just applying the formula and finding the answer. These kind of questions used to come in CSIR NET exam. I have seen this in last 3 to 4 previous year question papers. Similar kind of questions used to repeat. So you must know the formulas. Okay. So shall we move on to the next question? Okay. Okay.
Yes, ma'am.
Again, this thing we have discussed in some of our theorems, but you have to recognize which theorem have to be applied to which option. So f is given to be an entire function such that limit z tends to 0, f of 1 by a z, the modulus is going to infinity. Then f is necessarily constant. F can have infinitely many zeros. F can have at most minutely many zeros. F is necessarily nowhere vanishing. Means F does not have any zeros. So you think a little bit. You can apply theorems and then tell me the answer after just 1 minute. Everyone needs to think about these options. Otherwise, we can't do on ourselves for NET exam. Even if you are not able to do that, start doing that from now onwards. You will make it done for the September exam. At least if we are getting this part, we must suddenly remember what theorem. What is that?
We use 18th theorem.
Yeah, the 18th theorem. What does it say? If limit z tends to infinity,
F equal to C to C, the entire limit z into infinity, f of z equal to infinity.
yeah, then
F of z is polynomial.
yes, it is a polynomial. Okay, So do you find any similarities here? Can we modify this into this? Instead of writing z tends to 0, I am going to write 1 by z is tending to infinity. Is that both same?
Yes, ma'am.
Yes. Let
Yes, ma'am.
this be same. Now I am going to identify 1 by z with some omega. So now what is it? Limit omega tends to infinity, mod f of omega is going to infinity. So we can apply this result and we can say that f is a polynomial. Okay, so you have the entire conclusion with you. Now look into the options. What is the first option telling you? F is necessarily a constant. We know that f is a polynomial, but is it necessarily a constant?
No, ma'am.
Okay, think of some examples then. The one which I said when someone asked about the converse of this thing. Think it. Can you find a polynomial that is
Constant
non-constant?
polynomial, then
Huh?
if we take constant, then it is contradict A, option A.
Yes. If it is constant, then what is it telling? As it tends to infinity, that modulus is going to infinity. No. We can just take the 0 function or 1, the constant function. So A is wrong. What is B? F can have. It is not that F is necessarily having. It is F can have infinitely many zeros. Is it true? Think. We have a polynomial. Can a polynomial have infinitely many zeros?
No.
No, it is at most its degree, right? So this is again false. So the third option is saying that f can have at most finitely many zeros. That is true, right? Being a polynomial. And what is the fourth option telling us? F is necessarily nowhere vanishing. Check. Polynomials can be nowhere vanishing, but not in complex plane, because every polynomial has a root. So what is D?
Wrong, ma'am.
Wrong. So clear how we are using simple kind of results to do each and every options of a question. In this way, you have to sort out when you are in exam hall. If you are practicing on your own, then you can apply anything you wish and find answer, but it will take time. So if you are in CSIR NET exam, we are not going to use other things unless other than it is required. So we use simply results and negate the options. Okay, so the next part. Okay, you are given an entire function whose image is a proper subset of C minus Z0. Then f is a polynomial, f is bounded, f is unbounded, and f is a constant. Which of the following are true? So think a little bit. For this question, everyone must get an answer because we have used a straightforward result which I have stated. Don't tell the answer now. Everyone have to think what is happening. Could you figure out the theorem behind this?
Little Pickard's, ma'am.
Yes, good. Little Pickard's theorem. What does it say?
entire unbounded function can omit at most one point.
No, it does not say anything about unboundedness. It says a non-constant analytic function. Non-constant analytic function has range C or C minus a singleton. Now come to the question. What is it saying? It is entire. Okay, so this part is okay. It means entire. Okay, not analytic alone. Entire. Analytic in the entire complex plane. Okay. So entire is given, and you are also given that it is not taking C minus Z0 completely. Means the images are proper subset of C minus singleton 0. So from Little's theorem's converse, what can you say? It is constant, right? So now the answer is constant. But here comes the problem. We will get that it is a constant, okay, and we will tick that and move on for the next question. But if it is a C part, be careful. If it is a B part, then fine. You will not be having any other options relating to this option, relating to the answer. So you may tick this thing and move without even reading the other three parts in B part. But in C part, you have to carefully look into these parts also. We know F is a constant. So clearly F is bounded. Clearly F is a polynomial. But F is not unbounded. So this is the answer. Okay, even if we know little Pickard's theorem, even if we could figure out the answer that F is constant, we may still lose the mark in net exam. Why? Because of carelessness. We will take the constant and go. But be patient and look into each and every option C part. Okay, shall we move on to next problem? Okay. Is this method okay with you? Can everyone follow this method? Or should I modify some?
Yes, ma'am, we follow.
Okay, fine. So next question is that F be a non-constant analytic function on C. Suddenly what must come into your mind?
Pickard
Non-constant analytic function on C.
theorem.
Okay, you can use Pickard's theorem, you can use Liabilities Theorem, and so on. Because analytic is given on the C part, so it is entire. Analytic on C means entire. So you can use Liabilities, little Pickard's, everything must come as soon as you read the first line of the question. Then, which of the following is false? This is the next thing that we use to make mistake in exam. We will be knowing the proper answers and we will be picking exactly the true answers for that. This often happens in C part. If it is B part, we will be getting 3 options right. So we will be knowing that, oh, the question was false. So in C part, be careful, read the question properly. It is asking which of the following is false. So let us look the true parts first. We know that it is non-constant analytic. So by Liabilities theorem, it is unbounded. So this is a true one, but the option is false. Right, because it is asking false. Now, non-constant analytic function is an open map. That also we saw, right? This again is a true statement, but according to the question, the option is false. Now let us move on to the easier part. What is this? Image of F closure is C. Means what? Little Pickard's theorem is going to tell you that image of F is either C or it is C minus a single point. Right. What is closure of C? C. What is closure of C minus single point? What is it? C again.
C, ma'am.
So this in fact is a true statement, but this is false. So directly we can say, okay, this is the answer, but we have to look into it when we are doing the practice of question papers. So what is it telling? There is an open connected domain U on which f is never 0, but f restricted to U attains minimum at some point of U. What does it say? Okay, so you are given a neighborhood U, and they are telling that f is never 0 in U. In U, f is never 0. But what they tell is that it is bounded by minimum. That is, mod f is strictly greater than, mod f is greater than or equal to some constant, say small m, which is strictly positive. Okay. So what does this mean? Range of f is not going to take the values in this disk mod z less than m. Right. So range of f is going to miss more than 1 point. So it contradicts little Pickard's theorem. Understood how the C part is false? Understood? If not, yeah, I will. So what is the C part telling? You will be getting an open connected domain U. Okay. For which f is never 0. Means f is not vanishing inside U. But what are they telling? F is attaining its minimum. Maybe we can use maximum modulus principle. Maybe we can use little Pickard's theorem. That all must come into our mind as soon as you see this thing. Minimum at some point in the interior of U. Okay. So what they are telling? You are getting a neighborhood inside which f is never vanishing, but f is always greater than a positive quantity. That is what minimum is attained. Right. Am I correct? You understood? Okay, till this you understood. Okay, then what we are going to conclude is that, okay, consider the complex plane. Then what we got is that the range of f is actually this set. Sorry. This set. This portion, the portion which I color in red, is not included in range. Where this is some m radius ball. Understood? What is the definition of this thing? Mod f is always greater or equal to m. Means range of f is contained in this part. Okay. So range is going to miss at least 2 points in complex plane. You understood? Still you didn't understand? No problem, ask me. Okay. So range is going to miss 2 points means it is a contradiction to little Pickard's theorem. So C is a wrong statement. Since the question is false, it is the answer of the question. Okay. So we shall move on to the next question. Again, see the example which came into my mind during I was explaining the Cauchy integral formula. You can directly calculate this thing. What I have written is you are given a circle centered at 1 of radius 1. Okay. Then you are given that the orientation is also positive. Is clockwise. Now you are just asked to find the value of this thing. You may do it within 15 seconds. Okay, start.
Option D.
Okay. Hope all might have done this. If a blind person is trying to answer this question without knowing Cauchy's integral formula and so on, they are so tricky that we will be having one and minus one as singularities. And then maybe this may be the answer because 2 pi a and all is coming. They will be ticking. But if you spend just 15 minutes, you will be reaching the correct answer. Sorry, 15 seconds, you will be reaching the correct answer. So how to approach this function? E power z by z square minus 1. What are all the singularities of this function? Actually, the singularities in the complex plane is 1 and minus 1 because this is actually z minus 1 into z plus 1. But minus 1 is not at all included in the interior of C. So I am not even bothered about minus 1 here. So I can take my Fz as this thing. And then I can make it like this, right? Now I have to integrate this. Then again I can use Cauchy's integral formula. What is it telling? It is 2 pi I into f of, what is the singular value? 1. So what is f of 1? It is 2 pi I into e power 1 by 1 plus 1, which is 2. So it is just pi I e. Clear? This is also asked in the previous year question paper. So such questions exist and people do use to regret complex analysis while writing CSIR NET exam. I strongly suggest you to look into the basics of complex analysis so that you can score full in complex analysis. Complex analysis, topology, linear algebra, real analysis. These 4 are the main scoring areas in CSIR NET exams. If one is really fond of differential equations, then they may score more in differential equation part. But still, if you are trying to learn a little bit of complex analysis, as we do problems here, then you will be surely clearing CSIR NET exam. That is the main reason I selected complex analysis also. Okay, so this is little bit tricky, but let's try if you can do on your own for just 2 minutes and then I will discuss. So the question is, you are given a function, a non-constant analytic function from unit disk to C. Okay. So suddenly you will be getting some theorems in your mind. Okay, liability cannot be applied because it is not entire. It is only defined on a domain of C. But you can use Pickard's theorem, then what else? Overlapping theorem, so on. Yeah, identity lemma. That is the main theorem. Whenever you see such things, equalities between some points and functions, or there is some limiting process, say 1 by n and all, we will be thinking about, okay, 1 by n tends to 0. What is there in it? So we have to think like that and then approach the problem. If we are just reading, okay, this is given, what I should do with this, and I am searching for some function satisfying this thing, it will not work. So as soon as you see tips like this, you must remember the theorems corresponding to that. So as one girl pointed out, we have to use identity theorem. Okay, you understand the question well, good. So it is a non-constant analytic function. Then they are claiming that there exists an f satisfying the property 1. It is property 1, okay. F of 1 by n is equal to f of minus 1 by n for, which is equal to 1 by n square for every n in n. The second property is that we have a function satisfying f of 1 by n is equal to f of minus 1 by n, which is equal to 1 by 2n plus 1 for any n in n. Then they are giving, okay, 1 and 2 are true, 1 and 2 are false, 1 is true, 2 is false, 1 is false, and 2 is true. Think a little bit. If you can answer this problem, then you are confident in complex analysis. If you can't answer this problem, don't worry. It is a harder problem in complex analysis. None other questions harder than this is going to come in CSIR NET exam. So you may try this and reach your goal. Okay, try at least one function that you have that you can satisfy one or two. That is fine. So that you can get, okay, one is true or one is false, like that. Are you familiar with any function? Remember, it must be from unit disk to C. Instead of doing the entire identity theorem first, just tell me, can you find some function satisfying 1 or 2? Just by trial and error.
Ma'am, one is
Yeah.
true. F of z equals to 1 by
Is
z
it
square.
1 by z square?
No, just only z square.
Yeah,
Only
only
z
z
square.
square. So that is the observation, right? So we are getting these observations because we are practicing problems. So you consider the function f of z equal to z square. This is clearly non-constant and analytic, and it is defined on entire C. So no matter, it is defined on D also. Okay. So is it satisfying 1? Yes, because 1 by n, if I put the value, it is 1 by n square. Even if I put minus 1 by n, it's still 1 by n square. Okay, so the question says that there is a function. Okay, so I got a function. So 1 is true. 1 is true. Okay, try to find some function with 2.
Cannot find such a function.
Okay, it's because you know the identity theorem, right?
Yes, ma'am.
Yes, that's the thing. Okay, so we are trying to find a function with f of 1 by n and f of minus 1 by n is something. But with our knowledge, we couldn't find any familiar functions for that. Then comes the role of theorems. So what actually you need is that you need something like f of z. Say, if I am considering 1 by n as I said, what is this thing? F of z is equal to 1 by, first I will modify this 1 by 2n plus 1. I will give 1 by n by 2 plus 1 by n. You agree these are same, right? Okay, are they same?
Yes, ma'am, same.
I'm just asking you 1 by 2n plus, yeah, okay. So I am defining a function, maybe not f of z, maybe g is.
Is it by 2 plus z?
G is at, yeah, it is z by 2 plus z. So I am looking into this function. What made me look into this particular function? This condition made me look into the particular function. Okay. So we already have some FZ. We are supposing that such a function exists. Okay. Then you take E to be the set collection 1 by n or even collection minus 1 by n. Anything is fine. If we take E equal to collection 1 by n alone, then again it's fine. Or minus 1 by n alone, then again it's fine. Okay. We just take a subset of our domain, which is useful to us. So on E, what can you tell about F and G? The way we constructed G was such that F is equal to GZ on E, right? If you have any doubt,
Yes, ma'am.
okay, we will
Yes,
check.
ma'am.
F of 1 by n is given to be 1 by 2n plus 1. Okay, from construction, what is G of 1 by n? Just give into this formula. It is 1 by n over 2 plus 1 by n, which is same as 1 by 2n plus 1. So what we get on E, which is in fact a subset of D. This D I represent for a unit disk, okay? On which is a subset of D, I have F and G equal. So if I have one more step, then I can use identity theorem. What is that step? What is identity theorem telling? If F is non-constant analytic and G is analytic non-constant, and if I have G equal to F on a particular subset of D, and if V has a limit point in D, then F is identically equal to G on entire domain itself. So what now I have to figure it out whether E have a limit point or not in D. It's a natural answer. What is the limit point of 1 by n?
0.
Yeah, 1 by n converges to 0. So 0 is a limit point of a grid, but is 0 in D? D is the unit disk, right? This is D. So 0 is in D. So we got a subset of D whose limit point is in D, which implies by identity theorem, F must be identically equal to G on D. Got it? So in fact, we were talking about F only. There were no function other than F on D, satisfying this property. Okay. So if at all such an F exists, then F must be of this form. That is what we got. We are not claiming that such an F exists. What we proved is that if such an F exists, then F must be of this form. Okay, now let's plug into the values. What is F of 1 by n? We already seen that it is 2n plus 1. But what is F of minus 1 by n? What is F of minus 1 by n? Maybe here.
Minus 2 plus 1.
Yeah, it is set by 2 plus n. So if I am giving minus 1 by n, it is minus 1 by 2n minus 1, which is not equal to 1 by 2n plus 1, right? So what I am getting is that if at all such a function exists satisfying this property, it must be this function. But this function is not satisfying the other property. So there does not exist such a function. Understood?
Yes.
Okay, so what is the answer? 2 is false and 1 is true.
See,
It is C. Okay. So in this way, we used to use the identity theorem. You must be careful and you must know that whenever such a limit kind of thing with zeros of F exists, either you have to use a Cauchy-Weierstrass theorem, which is more advanced, or you have to use identity theorem. Most often it will be identity theorem only. Okay, then the next question. So F is an entire function and you are given A to be a set of Z in C such that its nth derivative vanishes that set, that point. Means it is the zeros of nth derivative of F. Then which of the following are true? If A is entire C, then F is a polynomial. If A is entire C, then F is a constant. If A is entire C, then F is a rational function and none of them. It is a very direct answer. Please be quick enough so that you can answer in 10 seconds.
No, option A.
Okay. Option A is true. That's all.
Option B also true, ma'am.
Option B is also true. Why? Because I have z power n minus 1 as my polynomial function. This satisfies f power n z is 0 for all z. But is this a constant function?
No, ma'am.
Okay, so this is false. What you are thinking is that if you get the answer as a constant function, then it is a polynomial, so A and B are true. But here we are getting answer as a polynomial function, so it need not be a constant always. Okay.
Okay, ma'am.
So what about the third part? See, what is a rational function, by the way? I think everyone knows, right? Should I explain it?
P by Q, Q not equal to 0, ma'am.
Yes, it's of the form Pz by Qz, where Qz is not equal to 0 for any z in its domain. This is known as a rational function. So it's a direct answer. Tell, you know it is a polynomial. Every polynomial is a rational function, right? You can take Qz as the constant function one. Isn't it?
Yes, ma'am.
So it is also
Yes,
true.
ma'am.
This is the trickiest part in C part. You will be figuring it out. It is polynomial. Okay, it is not constant, but we will not be looking into the further options. So please do check each and every option in the C part. Okay, this is a really nice application of the consequences of Cauchy's integral formula. Or the CRE, even with CRE we can do that. Try within say 20 seconds. Given f is analytic and this is not image, this is imaginary part of f and the other part is real part of f, the whole square. They are given that they are equal. Now you have to figure it out whether it is unbounded, polynomial, constant and all this. Everyone here must be able to do that. I am given a hint also, f is analytic. So use the CR. It's just a calculation and you must be able to do that. Okay, it's time. Someone tell. If you are still doing the calculation part, then it's fine. Take your own time and do. But at least you must try to do the calculation part. So the very first step that you must observe is if f is u plus iv, what is given? Image f, that is v, is actually a real part f square, u square. So f is given to be u plus iu square. Now what to do? This is what you have to think. Okay, without doing these calculations, I will tell you one thing. You can make it as u times 1 plus iu. Is that fine? Now consider the function 1 plus iu alone. Its real part is a constant. So what was the result that I specified?
Real part constant means imaginary part also constant. ma'am.
Yes, real part is constant means the function itself is a constant, which implies imaginary part is also constant. So what you have is u is some constant. Now look into f. What is it? It is a constant times a constant, right? What is it? Writing this thing is meaningless. It's just a constant. So what you got, instead of doing, okay, some ux equal to vy, let me take the derivative and do, no, nothing that. You will not be used to do such problems in net exam. If you are doing, then it's our mistake. No calculation theory, only theory part will be there. Nothing related to calculation will be needed. There will be some tricks like this through which you can get to the answer very quickly. Okay, so you have to figure out what is the quickest way to go. That will come only through practice. So now you can answer this, right? We got f is a constant function. So unbounded, wrong. Polynomial, yeah, being constant, it is a polynomial. It's a constant, yes. None of this, wrong. Clear, right?
Ma'am, can you explain the CR equation also, ma'am?
Okay, ux equal to vy, right? What is v? U square, right? So what is it? 2 times uy times u, right? 2u times uy. Now, what you have? Uy equal to minus vx. So what is uy? Sorry, what is minus vx? It is minus 2u times ux. Okay. Now what we have? We have some 2u kind of thing common, right? We will so take it into the other part. Ux by uy, it is 2u from this equation. And from this equation, it is minus uy by ux. Okay. Then multiply. It is ux square plus uy square equal to 0. These are all real valued functions, right? So square of two things equals 0 implies each part is 0. That is ux is 0 and uy is 0. Means u is independent of x as well as independent of y. Means u is a constant. Now come back to f. What is f? It is u, which is a constant. From plus I times what is v? Again u square. It again is a constant square. F is a constant. This 2 is easy unless you recognize that there is a 2u common here. See, if you are doing these things, you will be thinking of, okay, where to substitute what and so on. So, it is a little bit tricky to do this way, but it is easy to do this way. Right?
Thank you, ma'am.
Okay. Then next. This is a straightforward question from radius of convergence of a power series. You can all do that. So try. You are given a power series, but it is not like a single definition for an. It is piecewise defined. Means for n odd numbers, you have 1 plus I power n. And for n even numbers, you have 2 minus I power n. And we know that this is the series. So now we are asked to find the radius of convergence. You remember the formula for radius of convergence?
Yes, ma'am.
What is the formula?
Yes, ma'am.
Limit supremum mod an power 1 by n, the whole inverse, right? We are finding r, not 1 by r. So try doing this thing. Because we have a power n here, it will be useful to do this formula. It's fine if we do with an by an plus 1 also. Nothing matters. but it's good to use this formula. Okay, do and tell. You have to understand the definition of limit supremum rather than limit. Here you have two different subsequences. So you have to take the limit of the separate subsequences and then identify what is the radius of convergence. What do exactly the meaning of radius of convergence is? If you are telling that R is a radius of convergence, it means that for any point inside the radius centered with origin and radius R, it is convergent. So from first part, when it is odd, we will be getting some R1. Okay, let it be small R1. From second part, we will be getting some R2. I don't know which is big and which is small. I'm just drawing. So what we have for n odd, the series is converging only here. For n even, the series is going to converge in this bigger radius circle. So the series consists of both terms. So the series to be convergent, it must be the minimum of R1 and R2, right? So this is the region where the series is going to converge. So you find R1 and R2 separately and find its minimum. That's all.
Ma'am, option B.
Yes, option. We have only less time, so I will be a little bit faster. If you can't follow, then please do let me know. So what is limit supremum of a n power 1 by n for odd thing? It is 1 plus i's modulus. What is 1 plus I modulus? It is a root and it has a inverse. Okay. 1 by root. Okay, the second part, what is it? It is 4 plus 1, that is root 5 inverse. That is 1 by root 5. So which one is larger, 1 by root 2 or 1 by root 5? 1 by root 2 is larger. So the smallest thing is 1 by root 5. It's how we find the radius of convergence of series. If it is given a single series, it's fine. You will be doing it. But if it is given in terms of limit supremum and two subsequence, you must be able to do this because it's a simple question. If you're leaving this question and coming, then it will be really bad because we will be getting 3 marks for this. It's a B part question. Okay, then next. This again is an application of several theorems that we discussed. So you must look into it. Okay. What is it telling? Given it is entire function, means it is analytic on entire complex plane. Then what we have to do is that see the first option, whether this implies it is a polynomial. That is the question C. Then F is a polynomial if, what is this? They are claiming Q if what happens to P. So the P's are given here. So you are checking P implies Q is true or not. So you have to go to each option, then check whether it is a polynomial. So do that. We'll be giving 2 minutes for this. You understood what to do, or should I repeat? Because when I'm giving these 2 minutes or 1 minute, each and every person in this meet should think. If you are not getting the answer, it is not a matter, but you must think. Only then you can motivate yourself and qualify JRF.
Ma'am, A and B correct.
Okay. What about C and D? remember about some theorems that I have said. D part was exactly
Yeah, from last theorem.
yeah.
Last theorem A and B are correct, C and D wrong.
Oh, C and D is wrong.
Polynomial then must be limit z tends to infinity modulus of fz must be infinity.
Why so? The question is reversed. That's what I asked you. How do you understand the question? It is P implies Q that they are asking. That is, it is given that limit set tends to infinity mod f is m for some finite m, and you are asked to figure it out whether f is a polynomial or not. Whether f is necessarily a polynomial or not. It's not the other way. You are given a polynomial f and you are asked to find whether C satisfies or not. No, not that way. You are asked to find given limit set tends to infinity mod f that is m, then is it necessarily a polynomial? Think once again. What is the meaning of limit set tends to infinity mod f that is m? Explain in pure English language, not mathematical. What does it means?
Ma'am, f is bounded.
Yeah, yes. So as we move on to the infinity part, then it is equal to m or maybe less than or equal to m. So what does it means? In this ball m, outside this we have not m, sorry, some natural number or some real number. It's fine. We take a natural number. So the meaning of this limit is that there is a natural number n. Beyond this n, whenever I take a modulus bigger than n, then by the definition of limit, it says that this is n. True, right? Or maybe less than or equal to m because of the limit kind of thing. So what is it meaning? On this disk, it's not a disk, it's an unbounded disk. On this disk, it is bounded. But it is an analytic function and B0n or mod z less than or equal to n is a compact set in C. So analytic function on a compact set is always bounded. So f is bounded here plus f is bounded here. So f is always bounded. Now think f is entire and bounded. So
F is polynomial.
yeah, Liabilities theorem says that f is a constant. So constant means it is a polynomial, right? So this is true. The one who asked me about the C part is wrong. Are you clear now?
Yes, ma'am. Yes.
Okay. Okay, so this we discussed, and this is a straightforward application of the result that I gave, right? If limit, limit and all is not required. And this again is a result. If mod z is less than or equal to some constant times z power n, then it's a polynomial of degree at most n. So it's a polynomial. And this again was a result. If it is unbounded in infinity, then it is a polynomial. And what is this? This is a straightforward application. This means that after a stage n, everything is 0. So this precisely is an into z power a power maybe n into this thing plus so on up to a naught. Right, this is a polynomial. So a is also true. Look, in this option, 4 options are true. So there are some questions in CSIR NET that each and every option may be true. We cannot predict. So we have to look into each and every options. So the next question, it's again simple. This simple means interior of image of. Yeah. Okay. So read the question carefully. F is a non-constant entire function As soon as you see this, what all things will pop up into your mind? Liouville, Pickard's theorem, open mapping theorem, identity theorem. Okay, these must come into your mind. Then look into the options and select which theorem can be applied. So, what is there? F is a non-constant entire function. So, what can we say from Liabilities theorem? F is
Unbounded.
yes, unbounded. What can we say about Pickard's theorem? What can be said about image F? Yeah, it misses at most one point, right?
Yes, ma'am.
At most I am writing like this. It misses at most one point. So what is given here? Its image F has interior null set. Image can be either C or C minus some set not. What is the interior of C? Again C. What is the interior of this set? This is an open set, right? So its interior is again this thing. Sorry. So it's not empty. So this option is false. Understood how we are using Pickard's theorem?
Yes, ma'am.
Okay. What is the second option? Image F intersects every line that passes through origin. So image F. What is image F? Suppose image is C, then it is clear C is intersecting every line passing through origin. And if I am supposing image is say C minus Z0, I am making a hole here, okay? The C minus Z0 is the image. What are they asking you? Image intersects every line that passes through origin. So the only option that you can get confused is what about this line? This line is again intersecting with the image. Why? Because image is full here, right? It is not only this point, it is missing a single point from image. It is not the case that image set intersection C minus Z0 is empty. Understood? Understood what I was telling?
Ma'am, can you explain once, ma'am?
Okay. What are they asking? Image F intersects every line that passes through origin. So one line that passes through origin is this. What is image F? It is C or C minus Z0. So this intersects C or C minus Z0, right?
Yes, ma'am.
Okay. Then the only possibility is that you may be confused with this case. C minus Z0 is the image set. And there is a line passing through origin and Z0, right? But what they are claiming is that image F intersects. It is not equal to. It is intersects every line passing through it. Yeah, clearly origin intersects this line and image. Or even this point intersects this line and its image. Any point other than Z0 in this line is going to intersect its image, right?
Yes, ma'am.
Okay. Am I confused you? You're fine, right?
Yes, ma'am, fine.
Yeah. So this option is true. And then what is happening? Instead of line, they are taking some disk. There exists a disk in C, which is disjoined from F. So the image of F is actually this thing. So the only disjoint set of this range is what? The disjoint set from this thing.
Singleton Z0.
Yes, singleton Z0. But is this a disk?
No, ma'am.
No, it's not a disk. So what they are claiming? There exists a disk in C which is disjoint from the image of F. It's false. Now, what is the last option telling? Image F is contained, image F contains all its limit points. What is
Ma'am,
image F?
Z0 may be disk with radius 0.
Disk with a radius 0.
Yes.
No, that we don't consider as a disk. Radius is always a positive quantity.
Okay.
Yeah, I understood what you are talking is. You can take a disk or radius like this. Right. But what happens here? Radius itself is 0, but radius we consider always as a strictly positive quantity. Okay. So then the last option is image F contains all its limit points. Again, what is the possibility of image F? C or C minus a single point. What are the limit points of C? C itself, it contains it. What are the limit points of C minus Z0?
C.
C, ma'am.
Oh, yeah, it is C. So it is not containing Z0, right? So it is false. Clear? Is it clear? Shall we move on to the next problem?
Ma'am, image of C is
Image of FF. They are asking that we know only image of F can be either C or C minus a singleton set, right? So they are asking this image is going to contain all of its limit points. What are the limit points of C? It is again C. What are the limit points of Z minus Z0? It is again C. In this case, it is fine, but there are cases where limit points are not contained in image. Can you tell one example? It is immediate. You give me a non-constant entire function whose image is not, whose image is C minus Z0 for some Z0 and its limit point is C. The limit point is always this, but you have to
1
say
by Z.
one non-constant analytic function. What?
1 by Z.
1 by Z, is it analytic?
Oh, no.
You are familiar with that example in a real case also. It is not going to miss a point, but it is going to miss something. Think about most familiar function that you know, which are analytic.
Exponential function.
Yeah, clearly exponential function. Will exponential function take the value 0? No. And exponential function is clearly non-constant analytic, right? So by Pickard's theorem, its image is going to be C minus Z0. So its image is C minus Z0, but its limit point is C, which is not contained in C minus Z0. That's why this option is wrong. Okay. Once such a problem exists, we cannot claim that, okay, I will go and take f is equal to Z. This is non-constant entire and I am getting its image. The complete points is in, limit points are also in C. Okay, then this is true. No. For true, you have to prove it. For false, you can give a counterexample. So we got a counterexample, e power Z. Because of that, the fourth option is false. Okay. Okay. Now again, this is a simple question. You can answer with C3 alone. F equal to u plus iv be an entire function. And we are given a Jacobian. What is a Jacobian given? Ux of a, uy of a, vx of a, vy of a. And it is given that this is a symmetric matrix for any ANC. Now you have to conclude one of these four, not one, any of these four. F is a polynomial, F is a polynomial of degree at most 1, F is constant. What? Is the question to me or? Okay, fine. So do it. We'll give just 30 seconds for this. The clue is use CRE and use the property that JA is a symmetric matrix. Because whenever see some specific terms in the question, remember that without using the terms, you are not going to get a proper answer. So try to use everything in a proper manner. Okay, we'll do together. What is the meaning of symmetricity?
Sneha, we
Yes,
will
sir.
get only 5 more minutes because we need to go for an interaction also. Okay.
Okay, sir. Okay, sir. So with the one question, I will stop. Or should I stop with this question?
Ma'am,
No,
A
you
transpose
can
equals to A.
explain one more
Symmetry.
question.
Okay, sir. Yeah. What is UXA equal to VY? Sorry.
Yes, ma'am. A transpose
Not
equals to
X.
A.
VXA equal to UY.
Ma'am, A equal to A transpose is symmetric, ma'am.
Yeah. So what is the
So we
property? These things are same, right?
Ma'am, uy
Yes,
equal to
ma'am.
vx.
What?
When uy is equal to vx.
UI. What is
U
UI?
uy, ma'am.
Ux equal
Y.
to Vy
Yeah, UY equal to VX.
minus of minus.
By Cauchy's CRE equations, we already have this is minus Vx. So Vx is minus Vx implies what?
Vx equal to 0,
Vx
ma'am.
is 0.
Yeah.
V equal to some
Similarly,
constant.
can we conclude something else?
V equal to some constant, ma'am.
No, purely if Vx is 0, we may not be a constant. We may be some functions like this.
Independent of X.
Yeah. V is independent of X. That's all we get. But there is still something to do with this. So now you considered U, Y, right? Why can't you consider the other thing?
Uy also 0.
Yes, Uy is also 0. So U is independent of Y. Independent of Y. So what we got is V is independent of X, U is independent of Y. But we can't find a way in which we can relate some UX or VY, right? Is there any method to relate UX and VY? So what is the next option? Try finding an F, right? Which is U is independent of Y and V is independent of X. Can you say some function? U is independent of Y. So I put X plus I times. What is V? V is independent of X. So I put this thing. Okay, I am taking F is equal to Z, right? This is the function F is equal to Z. Now check, will it satisfy the Jacobian is symmetric? What is UX? 1.
Ma'am, F equal to U plus IV. How to write U equal to X, ma'am? Independent of
No, I
Y.
just took a function. It is independent of Y, so I am just taking a function. It is not that U is always X. No. Understood?
Still not clear, ma'am.
Okay, this is my assumption. Suppose F is equal to this thing. I have got that if these things happen, then U is independent of Y. And if these things happen, then V is independent of X. Right? So I just took U, okay, U equal to X. Okay, then V be Y. Then what is the Jacobian? Uy is 0.
Ma'am, 1, 1, 1.
Okay. So this is a symmetric matrix, right? So what all things can we avoid? F is constant? No. F is an identity function. F is a polynomial of degree less than 1? No. F is a polynomial of degree equal to 1. F is a polynomial? Still we are there. Okay. F is a polynomial of degree less than or equal to 1? These things we have to discuss. How? Okay, since lack of time, it is easy. I will share you in what's Max Aspirants group or something like that. You try first. If someone get the answer, then please put into the group. Also, I will be giving you 2 more problems to, not 2 more, 5 more problems to do. Maybe you can take a screenshot faster. First, take the screenshot of this problem. Since I have written and there is no time for now, I'm doing that.
Yeah,
So you can-
Sneha, you can show that questions and they can take screenshots.
Yeah.
And later we can share the workouts.
Yes, sir. Yes, sir. Sure.
Along with the recording of the class.
Yes, sir. Sure.
Yeah.
Take the screenshot, please. Maybe I will be giving you 5 seconds for each slide, then take fast. Okay. If you are able to do this problem, then I am satisfied that you understood my each and every theorem. So this is a very important problem. Try to do this. Okay. Okay, that's it. Shall I minimize the presentation?
Ma'am, 14 number, please. 14 number.
What?
14 number problem.
14. You need 14.
Yes,
Thing.
ma'am.
Okay, take it.
Okay, ma'am.
Okay, thank you.
Thank you, Sneha, for today's nice session on different types of problems from the area of complex analysis.
Thank you, sir.
I'm sure that many people will be really get benefited out of this discussion, and we have given around 18 problems, and out of which around 13 or 14 being discussed in detail. The remaining things you can practice, and we will share the detailed workouts along with the recordings of this video. Now it is the time for interaction. As in the beginning, when I introduced Sneha, I told you that Sneha is now pursuing PhD at ISI Bangalore, and she has a good record of academic records. So you can make your comments about the class, or you can ask anything related with the studies or going to PhD, like that you can ask. So let us come forward. Before speaking, please introduce yourself, and please keep your video in the on mode. Yes.
Yes, feel free to ask.
Yeah.
Whatever things I can answer for you, I can answer. Feel free to ask anything related to mathematics.
Good afternoon, ma'am. Ma'am, I am Diya Shaha. I am pursuing my M.Sc program in IIT Bhubaneswar, and I am also preparing for coming NET exam. Ma'am, today's session is very nice, and I like how you at first you give the important problems first, because it is very like when we are doing problems sometimes in book, to find those problems it's very sometimes it's very hectic and we cannot find the important problems. So if you have given them in 1 or 2 pages, so it is very nice. And the problems are also very nicely you have explained very nicely, ma'am. I like the class very much. Thank you, ma'am.
Thank you.
Uh,
And
Thank you.
one thing I have a suggestion is that whenever you're trying to prepare for CSIR NET exam, please do practice all the previous year question papers. Okay. So instead of learning the books that we are learning in our M.Sc or B.Sc, what all, I do recommend you some YouTube channels. See on that videos, it will be really helpful for you. And after that, you try to practice your question papers. First, you try doing one question paper, not in 3 hours. Let it be 3 days or 4 days, no matter. You do that. After say 2 or 3 question papers, then you restrict your time and then start doing the question papers in time. If you practice this way, sure you are going to succeed.
okay, ma'am. Ma'am, one more question, ma'am. How do you prepare for ISI exam?
Means the preparation, I didn't went for any coaching and all. First thing was I used to listen to my class lectures, maybe the M.Sc lectures, the B.Sc lectures, and so on. And I used to watch some YouTube channels. I used to hear their video lectures. I used to follow Kumareshan's YouTube lectures. It's a part of MTTS, so I have attended MTTS programs also that helped me really a lot. And you may find your own way to doing that. The main thing is that you must understand the theorem well. Even if you are not able to understand the proof well, you must understand what the theorem is going to tell you. And you must be able to apply that theorem in a different manner. So that depends on how you work.
Like, ma'am, in ISI exam, there are some subjective questions per bit in for that, ma'am, what is your suggestion to prepare?
There are some prescribed books for that. If you are looking topology, I suggest you Munger's topology book. And if you are preparing for algebra, it's my personal suggestion. Is it from my? Okay. And for algebra, you can refer ℸ𝕇𝕚𝕚 text. Then for real analysis, maybe the measure theory part will be asked frequently in ISI exam. So you prepare from real analysis full and the text. Okay. If you are not getting sir will be able to send you. I will put in our group. Okay. So you means reading a book means you no need to read it from first till end. Just understand the concept, what is going on in the subject. What are the theorems trying to tell you? What is the situation from where we arrived into such a problem, and what are all the results that we are doing in that problem? Like that. You just need to know about the results. It is not a hard thing.
Yeah, Sneha, while you preparing the PDF, you can include the references at the end, then that will be useful for our participants.
Okay,
And
okay, sure.
Thank you, Dia. Let me tell you
Thank you,
something
sir.
more. Yeah, let me tell something more. See, Sneha, our Dia is now studying in IIT Bhubaneswar, and she qualified CSIR NET with JRF in the first time itself, and she is again writing to improve the rank.
Fine.
And she is really very gifted and very active in our group. And Dia, one more thing, ISIs are very good institutes for mathematics, especially ISI Bangalore is having very good faculties. So if you are interested to pursue something in functional analysis or a hardcore analysis like a harmonic analysis or yeah, something like that, then ISI Bangalore will be a good choice. So keep ISI also in your dream
Yes, sir.
institutes.
Selection list.
Yes, sir.
And also, Sneha qualified NBHM exam, doctoral fellowship exam NBHM in 2021 among the 41 recipients in that time. So NBHM is also should be a target for the right
Yes.
students. So try the all that to clear all that things.
Yes, sir. I'll try my best, sir.
Yeah, yeah.
All the best.
all the best, dear. Okay, others. Okay, please do come forward.
Hello, ma'am.
Yeah.
Yeah.
My video is visible.
Yes,
It's fine.
but yeah, but the
Actually,
light is
there's a
somewhat.
yes. Actually,
Yeah,
there
it's
is a
okay.
power cut. That's why.
Yeah, oh, yeah, yeah, yeah. Okay, Shiga, please introduce yourself first.
Ma'am, my name is Shikha. I'm from BIT Mesha, second year MSc student, and preparing for CSIR NET exam. Ma'am, your session was really nice. The summary that you have gave of complex analysis, it was really good and crisp. And ma'am, my question is that except NBHM, what all scholarship exam we should give for PhD exam? PhD.
Okay, mainly there are 4 types of exams. Mainly people used to clear CSIR JRF, NBHM, GATE, and then INSPIRE is there. So INSPIRE is given only to the rank 1 students of several universities. That also they will be giving on the basis of some selection, not to each and every university's first rank students, not like that. They will call for the INSPIRE fellowship application. On the basis of your application, if you got first rank in your MSc, or if you are already an INSPIRE fellow at your college, right from your 12th standard, then you can avail INSPIRE fellowship for PhD. But the amount is really less when compared to the JRF and NBHM and GATE and all. So in case of GATE, it is you have to qualify the GATE exam, but just qualification will not lead to a PhD. You will require a rank below, say, 20 to get admission in prestigious institutes. But if you are around between 100 or 150, then it's fine. Someone will be calling you for the interview, and if your performances are good, then you will be getting an admission on the basis of GATE. And if you're a GATE fellowship, GATE is not going to give you any fellowship. The institute will be provide you the fellowship. So I think the institute fellowship is same as that of CSIR JRF fellowship. It is 31,000 per month, plus the contingency or HRA or whatever things comes with that. Okay, and CSIR NET and NBHM are the main other things that you know, right? The procedures and things.
Yes, ma'am. Thank you, ma'am.
Thank you,
sir.
Shiga. Thank you, Shiga. Let me add one more thing in that. See, if you have got admission for PhD in a premier institute like IIT, then definitely you have one more option. There is a Prime Minister's Research Fellowship.
Yes.
So you can try that also. But for that, you need to get admission in a institute like IIT. Only few institutes are coming under that PMRF scheme. Okay. Yeah, others.
Some of the ICES are also included.
Yeah, yeah. Some centrally funded institutes are included.
But in ISI and IMSc, CMI, IISc and all, you cannot apply for PMR.
Okay. Yes, Sakshi. Yes.
Yes, ma'am.
Yes.
Good afternoon, ma'am.
Good afternoon.
Myself, Sakshi. I've just completed my B.Sc Mathematics honors from Delhi University.
Nice.
I'm targeting CUET and DUET right now. And the session was very helpful as complex analysis come in the CUET entrance exam. So
okay.
Thank you for your support and help.
Okay, thank you.
Thank you, Sakshi. All the very best for CUET exams.
Thank you, sir.
Yes. Others?
Hello, ma'am.
Yes.
Yes, Gayatri.
I'm Gayatri. I have studied in Miranda House College, Delhi.
Okay.
You have taken a very nice class. The problems and the explanations for the answers was very clear. And you have explained everything so slowly. So it was easy to understand. Thank you, ma'am. Thank you, sir.
Okay, thank you.
Thank you, Gayatri. Others? Yes.
Ma'am, your mic is muted.
Yeah, it's okay now, Alina.
No, still I can't hear.
So I don't know what happened, but I am hearing.
Oh, okay.
Okay. Alina, continue. Yes. Yeah, thank you. Yeah, thank you, Alina. Any others? Okay, please do come forward and speak. No, no need to hesitate. Venkatesh.
Yeah, very useful, sir. Useful, ma'am. Thank you, ma'am.
Thank you. Venkatesh, you introduce first. Yourself first.
I'm Venkatesh. I completed M.Sc MPhil. I'm studying for a NET exam with guidance of Vinod Kumar, sir, from Tamil Nadu, Ponneri. Very useful class, ma'am. Complex analysis. We learn more and how to select options from 4 options. You clearly explained, ma'am. Thank you very much, ma'am.
Okay, thank you, Venkatesh.
Thank you.
Sneha, are you hearing properly now?
Yes, sir.
Okay.
Previously also I could hear you, but I could not hear Alina.
Okay, maybe due to some technical errors.
Yes.
Okay, any others? Harita?
Good afternoon,
Ma'am,
ma'am.
Yes,
please
Sakshi.
share these notes.
What?
Sorry, Sakshi. Please.
If possible, please share these notes which you have taught us in the class.
Yes.
Notes. Sir will be
Yeah.
sending the video lectures. If you need, I can send a screenshot of all these notes because PDF format, I think it's not available in the external app.
Okay. Sneha, you better to take the screenshots of all that and we can make it as a PDF and share.
Yes.
Okay.
Okay.
We will share it along with the recordings, Sakshi.
Okay, sir.
Yes. Narasimha, you started to say something. Please.
Good afternoon, ma'am.
Yeah.
Yeah, good afternoon.
My name is Narasimha. I am from Andhra Pradesh. I
Yeah.
have completed my master's, ma'am.
Okay.
Ma'am, here I am looking for CSIR NET cracking up to 2 years. Last
Okay.
year I can't.
But that's okay.
Ma'am, here my question was in so many universities is on there in India. I am looking for in district wise in state so many universities looking, but I am unable to join to that universities. In your mind, what you prefer for this way? I am looking go CSR NET get crack and join PhD or
see.
Or what? Or what? There is no
See,
choice of or.
yeah, I think Narasimha is asking about getting admission in some state universities along their entrance, through their entrances, I think.
Oh, he is asking about that.
Yeah.
Yeah, it is there. It is
yeah.
there.
Narasimha,
I have
he is trying
have
for CSIR net for last 2 years, but not cracked yet. So what to do? That is his question. Narasimha, where are you from?
So I
You're
am from
playing?
Andhra Pradesh, sir.
Andhra
Andhra
Pradesh. Okay.
Pradesh. Okay.
Okay. Okay.
I have already completed cracked Chittoor state level in exam.
Ha ha ha. Okay. So Sneha.
So there are some state level universities also. I know only about Kerala. There are CUSAT exams conducted separately. There are KSOM exams. KSOM is based on the CMI's exams, and they used to take from NBHM and INSPIRE also. So anyway, the better option will be to clear one of 4 things: GATE, NET, NBHM, or INSPIRE. If you are not so, then you may contact the corresponding institute and ask them about their examinations.
Yeah, Narasimha, I will tell you something. See, first thing is that you are not okay. See, unless you are avoiding the your try for CSIR net, you are not completely away from the field. Okay,
Yes.
you can try. You can keep on trying to crack that exam, and there is no problem in doing that. And if you are thinking that your time is okay, then you can try to get admission in some state universities. There will be some entrances that they are conducting their own. You can, and also some universities are providing some kind of fellowships also. So if there are that type of things, then you can go for that. But along with that, also you try to clear NET examination, because you know that is a must for becoming an assistant professor in a college. So that will be very useful, very helpful in getting a job. And also you can try one more thing. In some institutes and some college, some universities, there will be advertisements for project fellows. So along that also you can join. Sometimes they may take even no, even candidates without any NET or GATE, that they also can be admitted for such kind of project fellowships. And
later convert it into PhD.
Yeah. But anyway, even though you have joined for a PhD in somewhere, then also at least in the beginning years you can continue your try for clearing NET examination, because that will definitely an added flavor to your CV while you are searching for jobs.
Yes, sir. Yes, sir.
Okay. Thank you, Narasimha, and all the best for your preparations.
So one more question, sir.
Yeah, do us. Carry on.
Sir, I can choose any private universities like VIT.
Yeah, of course, no problem in private universities, but sometimes there may be the course fee and tuition fee, that type of things may be higher as compared to other institutes.
Sir, I have already choose VIT, but some work is not good for me.
See, in VIT, the maths department is a very good one. Last time we had a faculty from VIT to engage a session in our platform. So you can go through their websites and see the faculty profiles to see which areas they are working and from where they have taken their PhD and all that. With that, I think you can choose wisely some institute of your choice.
Yes, sir. Yes, sir.
Thank you, Narasimha. Any others?
So, am I audible?
Yes.
Hi, ma'am. I'm Harita from Marthoma, Kerala. I'm a final year B.Sc Maths student. I'm preparing for JAM. Your class was very great. It was a bit difficult for me. Still,
Okay, I understand.
You explain very calmly. You give time, and you also follow the MTTS style, and I really liked it. I'm seeing someone who still keeps the style. I have also participated in MTTS. Thank you so
Nice
much.
to meet you.
And I have to ask you, do you have any special type of advices for us JAM students for preparing for JAM? And were you following the YouTube channel of Commeration sir during your JAM preparation also?
No. In fact, I didn't had any plan to go to M.Sc for some IITs or an ISS or something like that. I was really homesick, and I used to go to my same college. I wish to go to my same college, so I was not preparing for JAM exams. In fact, only when the application was called for JAM, one of my sir told me to write the JAM. and I wrote the exam, and also I cleared it. But rank was not up to the mark to get an admission in in institutes. So I continued my MSc in my college itself. But I can give a suggestion that it doesn't matter whether it is a NET exam or a JAM exam or any competitive exam. Once you prepare the syllabus purely based on your BSc syllabus, what you are learning in the maybe University of Calicut, right? The University of Calicut syllabus is really good for JAM examination. So if you are thorough with the theorems that teachers are teaching in your class, and if you are aware of how to use it in a problem, then done. That's all. So it is no need to practice all the problems in many books. If you are, for example, if you are learning complex analysis, I think I learned Brown and Churchill. I think you also followed it. Are you having Brown and Churchill?
It's in the 6th semester. I'm in the 5th semester. We don't have.
So you will be getting into that soon, and you will be coming across these theorems which I said, because everything in this book is taken from Brown and Churchill, and it is purely based on my note in BSc. So with the BSc complex analysis only, I am explaining you the net problem. So that's enough, because there is no much difference between BSc complex analysis and MSc. Only some linear fractional transformations or something will appear, and that do play a role, but not that much in the net exam. Okay, so preparing for JAM also, it's the same thing.
Yeah, let me add something. See, for JAM examination, the complex analysis is not there in the syllabus, but for other PG entrances like CUET or some other exams, questions from complex analysis will also be there. And Harita, you can choose Sneha as your role model, and Sneha is very, a very good student who cleared all the exams and cleared BSc, MSc with first rank in Calicut University. So definitely she will be a right choice for you to model.
Yeah, you can contact me and ask me anything.
Okay, thank you so much.
Okay, thank you, Harita. Dharmendra, are you there? Okay, any others?
Yes, sir.
Yes.
I am Dharmendra. I am Dharmendra from BARC Visakhapatnam. Today's session was very nice and useful. I enjoyed mostly problems. Can you suggest? I did only BSc. And,
okay, so are you able to follow my lectures?
Yeah.
Okay, fine.
Can you
in
tell
Park,
about
in
your
Maharashtra
journey? Yes, sir.
What was your question? Can you tell about?
Your journey about CSIR NET preparation and PhD.
Oh, great question. So it was not known to me until my MSc that I have to clear that exam. I didn't care about any of the entrance exams till my first year MSc. So you are more advanced than me. Still, you are in your BSc and you know about all these things. So when I came to my first year MSc, all of our teachers told that in order to become an assistant professor, there is such an exam and you can clear it off. That's all. But few of them told that you must clear in first attempt. And that became a okay, I have to clear it in first attempt for me. And then I started practicing. So I used to regularly visit to my department and ask so many questions to them. And they used to give full support. And then I used to see some YouTube channels at night. And most often I suggest don't sit and read a book completely for CSIR NET exam. It's not going to help you that much. It It will definitely help you in your mathematical career, but it is not going to help you in the competitive exams. You must try to understand the theorems and what it is going to tell you. So better read the theorems first. If you are not following anything from that theorem, go back and visit the definitions. Okay, that will be a better way to approach this. And you need to practice the question papers your own. If you are able to get 90 marks, say out of 200, while you are practicing in your home with question papers, then fine. If you get around 60 to 80, then fine. For first attempt, it is fine. And then you try to improve which all area should I focus. And first try to understand whether you are good at analysis part or PDE part. Because in both cases, you can clear NET exam easily. The linear algebra part will be familiar for each and everyone who is fair with analysis and differential equations. So you have to pick the problems properly, and then don't try to do scatterly. Okay, I will do some complex analysis, I will learn some analysis part, some algebra part. Not so. If you're learning linear algebra, learn linear algebra thoroughly, so that out of 20 questions may they ask for B part, you can score maximum of 20 and minimum at least 60. That's enough. That mark is enough. Okay. And this was about my CSIR NET preparation. And right from my M.Sc, I decided to do my PhD. In whichever institute, I am sure that I will be doing my PhD. And as God wishes, I came to ISI, nothing more.
Yeah, Dharmendra, your dedication and devotion is more important in your preparations. So you have to concentrate and do hard work. There is no other choice.
Thank
So
you.
all the very best,
Thank you, sir.
Dharmendra. Okay. Any others? Malavika or if anyone wish to speak, please do it now. Otherwise, we will wind up here.
Ma'am,
Yeah.
Yes.
which book you prefer for CSIR mathematics?
CSIR NET mathematics.
Yes, like
Narasimha, we will share a list of the books suggested by Sneha in the along with the PDF that we share with the recording of this class.
Yes, sir.
Okay. So any other? Yeah, Malavika. Yes. Malavika, you are. I'm not. You are not audible. Yes. Yes.
Yes. I'm Malavika, third year B.Sc Math student of Bijumon Guruvayurappan College, Kozhikode. Thank you, ma'am, for sharing your wonderful session for us and also for your effort. And since I'm a B.Sc Math student, I found little bit difficulty to follow, but I'm sure that it will be surely helpful to understand our upcoming classes. So thank you so much, ma'am. And also I would like to thank you for conducting such a wonderful session for us. Thank you, sir.
Okay. Thank you, Malavika. I think we are. Yes.
Ma'am, can you tell us about your PhD interview? How was
Could
it?
could you please introduce yourself first, if possible, with video?
Yes. I'm Kodai. I'm from Pondicherry, studying M.Sc second year in Pondicherry University, and I'm preparing for entrances. Yeah, I got some idea about entrance exams from whatever you told. Regarding interviews, how was your PhD interview? Can you tell us about that?
I attended around 8 to 9 PhD interviews, out of which I cleared IIT Madras, IIT Bombay, and ISI Bangalore. And each interview is different from one another because it's their aspect of view. Because if they are taking for functional analysis, then they will be asking you questions from functional analysis. But when we go for an interview, they will be asking you your choice first. So if you are interested in, say, linear algebra, you need not say functional analysis first. You can say, I am interested in linear algebra, real analysis, complex analysis, topology, whatever you like, you can say that. So they will be giving you some 3 choices of subjects that you can say, and they will ask from that. They will start from very basic questions, and how the way which you give the answer, they will pick that point and then ask the next one. So if you are answering like, okay, definition, and if then they will move on in a slow manner, and they will not be impressed in your performance. So if you are answering with a example, or you are applying, or you are giving some other questions to be asked, then they are more happy, and then they will ask more and more questions to you. And if your interviews last for long, then it seems that you are impressed. And if your interviews are short, then it seems that, okay, they are trying to avoid you. Okay. So for preparing for interviews also, preparing for anything is purely based on understanding the subject. So you first try to understand all the meanings of the theorems, then trying to find if it is a theorem, say if so, then so. Then try to analyze why its converse is not true. Then try to give some examples or find some examples why its converse is not true. And if you are in an interview, they will surely ask these kind of questions. They will give some supportive examples. They will ask to prove that this is, suppose, uniform continuity. Suppose you are given a function which is uniformly continuous, and you are asked to state that. You will be clearly telling that, yes, it is uniform continuous because of this reason or this theorem. Suddenly, they will give you some other counter examples and ask about the reverse of this thing. So, as soon as you are with a theorem, try to understand the converse also. Sometimes the converse exists. It may be because it is too difficult that we don't know. Sometimes it may exist a counter example for that. So prepare in that way. Any subject you are preparing, prepare in that. Learn a theorem, give a supportive example, try to find whether converse is true, or try to find whether there is a counter example for converse. If you do practice this manner, then you can surely crack any of the interviews.
Okay, thank you.
Okay, that is the important point. While learning anything, any result, okay, you have to understand the hypothesis and the conclusions in a very well manner. See whether all the hypotheses are needed and what happens if you relax something, all that things to be addressed. And also examples and counter examples are very important in any interview. So a deep understanding is needed as compared to the exams for interviews. A deep understanding of the ideas is very much needed. They will test you your level of understanding in any interview. So all the very best for all the participants. I think now it is almost the time we can wind up. Once again, I would like to express my gratitude and thanks to.
Actually,
Yes.
sir,
Yeah.
ma'am told some YouTube channel also. Can you tell once more?
Yeah, Dharmendra.
Yeah, that also will be given along with that PDF. Okay.
Yeah. Okay. Thank you.
Okay. So once again, I would like to express my sincere thanks and gratitude to Ms. Sneha for being with Math Aspirants, and I wish all success in her academic career. Thank you. Thank you.
Thank you, sir.
Let us wind up the session.
I also thank sir for giving me such an opportunity. It's great experience with my colleagues. Thank you.
Let us wind up here. Thank you.